Hi, in today's video we are going to see the second technique of closed hashing. So the second technique is quadratic probing technique. So what we are going to do means we are going to find it out the appropriate memory space when collision it occurs. Okay, so it is the second technique. It uses the quadratic polynomial formula for searching until an empty slot is found. So what is it? We are using two formulas here. One formula is h of k equal to 2k plus 3. So this is one formula for finding the memory slot. Usually whenever the collision it occurs, we are using this formula, that is u plus I square modulo m. So there are two formulas we are using here, whereas in the linear probing technique we are using only one formula. Okay, so if you have any idea about linear probing, better you refer my previous video. Okay, so now we are going to see this particular quadratic probing. So in quadratic probing, what we are going to do means we are going to find it out the index of each and every numbers which is given here. This is, we call it as key. So h of 3, what is it? We are using this formula, h of 3 equal to, what is it, 2 into 3 plus 3 modulo 10. So it is modulo m. Actually the formula it is modulo m. Okay. So modulo m. What is that? Already it is find it out in the, what is that, linear probing. The same we are going to do until the 4 iterations, 4 numbers. What is the value? It is 9. What is that? 2 into 3. 2 into 3 it is 6. 6 plus 3 it is 9. So 9 modulo 10 it is 9. What we are going to do means, in the 9th location I am going to store the value 3. So I am going to store 3 here. Okay. And like the way I am going to find it out h of 2, second number. So 2 into 2 plus 3 modulo 10. So 2 into 2 4, 4 plus 7, 4 plus 3 is 7. 7 we go to 7th location and we store the number 2 here. Okay. Then h of 9, next number is 9. So 2 into 9 plus 3 modulo 10. So what is it? 2 into 9? 18 plus 21. So it is 1. So we go to index number 1 and we store the value 9 there in the index. Okay. So what is the next one? h of 6. h of 6 equal to 2 into 6 plus 3 modulo 10. So 2 into 6 12. 12 plus 3 15. 15 means 5. So we go to 5th location and we store the value 6 there. Okay. Then next number is h of 11. So 2 into 11 plus 3 modulo 10. So what is 2 into 11? 22. 22 plus 3 25. So now the 5 index number 5 comes again. Up to these 4 iterations we are not, that is the index number is not repeating. Here the index number is repeating. Whenever this situation we call it as collision. So whenever collision occurs, how can we overcome in the quadratic probing means we are using this formula. What I said in this formula, what formula we are using? U plus I square modulo m we are using. Okay. So what is u plus I square? U, it is nothing but the collision memory location. It is 5 plus, what is it? We are using this formula with I equal to 0 to m minus 1. So I becomes 0 now. So we are using u plus, what is u? 5 plus 0 square modulo 10. What is the value? 5 plus 0 square 5. 5 modulo 10, it is 5. Okay. Already it is 5 is already filled. So that's why we go for I equal to 1. What is I equal to 1? 5 plus 1 square modulo 10. What is 1 5 plus and 1 square? 1 square is 1. 5 plus 1 6. 6 modulo 10 6. So we go to 6th location and we are storing this 11 number in the 6th location because it is free. Okay. So through this formula we are finding the new location, and in that new location we are storing the next number. So what is that? As usual we are finding this h of 13. What is h of 13? h of 13 equal to 2 into 13 plus 3 modulo 10. So 2 into 13, it is 26, 29, so 9 comes. What is that? 9 comes. 9 means, again, the same index it comes again. This is also collision problem. Whenever collision problem comes, we are using this same formula here. So that's why I becomes now 0. We are using the index, it is 9. So 9 plus 0 square modulo 10. What is 9 plus 0 square? 9. 9 only. So what is it? It is 9. So 9 means it is 9 already filled. So that's why we are unable to do. I becomes 1 now. So 9 plus 1 square modulo 10. What is 9 plus 1 square? It is 10. 10 modulo 10, it is 0. So we go to 0th position and we store the value. What is the value? It is 13. So 13 is stored here in the 0th position. Is the point clear? Now I am executing h of next number. What is next number? 7. h of 7 equal to 2 into 7 plus 3 modulo 10. What is the value? 2 into 7? 14. 14 plus 3? 15, 16, 17. 7. So 7 comes. 7 comes. 7 also already it is filled. It is repeating again. So that's why it is also collision problem. We go for this particular, what is it? Formula. So I becomes 0. What is the value? 7. 7 plus 0 square modulo 10 equal to, what is the value? 7 plus 0 square? 7 only. 7 already there. So that's why I becomes 1 now. So 7 plus 1 square modulo 10. So 7 plus 1 square means 8. 8 modulo 10, it is 8. So 8 is free now. So 8 is free means we are storing number 7 in the 8th location. So one here. Now I come to last. What is it? Last one is h of 12. h of 12 equal to 12 into, sorry, what is the formula? It is 2 into 12. 2 into 12 plus 3 modulo 10. What is the value? 2 into 12, 24, 27. Again 7 comes. 7 already filled. So it is a collision problem. So in collision problem, what I do? I have to go for this algorithm, this formula. I equal to 0. What is it? 7. 7. What is it? 7 plus 0 square modulo 10. What is 7 plus 0 square modulo 10? 7. So I becomes 7 already filled. So that's why I becomes 1 now. 7 plus 1 square 1 square modulo 10. What is the value? 7 plus 1 square? 8. So 8 comes. 8 already filled. So already filled. So that's why I becomes 2 now. 7 plus 2 square modulo 10. So what is it? I plus 2 square? 4. 2 plus 7 plus 4, 11. 11 means 1. 1 already filled. So that's why I becomes 3 now. 7 plus 3 square modulo 10. 3 square 9. 9 plus 7, it is 16. 6. We come to 6. 6 already filled. So that's why I becomes 4 now. 7 plus 4 square modulo 10. What is 4 square? 16. 16 plus 7, it is 23. So 3. So 3 means it is 3 is free now. So we are going to third index and I am storing the number 12 there in the third index. Is the point clear? So through this way only we are finding the free memory area whenever the collision occurs in a quadratic probing technique. So this is the second technique of closed hashing. I hope you understand the logic.